Okay, so you girls know the difference between a combination and a permutation. So a permutation,
that's when order matters, right?
That's when order matters, and a combination is you're just selecting. All right. So an example would be I did the example with you, the Lotto 649. Well, the Lotto 649 is you pick the six correct numbers out of 49 and you win the lottery. So you have like a 1 in 14 million chance of that happening. So obviously not great. However, if they said you had to pick those six numbers and put them in order, that becomes a permutation. You'd have a 1 in 10 billion chance of getting it correct, right? So basically what the difference between NPR is, so that's when order matters. Well, NCR or N choose R, that helps us just to remember that I divide by the number of ways in which I can order them. So whatever I select, so if I selected 6 balls from 49, I have to divide by the ways in which I can order the 6 of them. And that's how I take 1 in 10 billion chance to a 1 in 14 million chance. All right. Okay. So the combination questions that we worked with a lot was the ones where you'd have a number of boys, a number of girls. You got to select this many boys and this many girls. That was all combination stuff where there was no permutation involved. Okay. So we also did it with probability. So we've got a long a way of in the probability. We got a long. We did a lot of it. All right. So this shouldn't be too difficult on you. All right. 8 female students and 9 male students are running for 6 different or 6 offices on the student council. Executive team, how many selections are possible? Okay, so with no stipulation on it, you need to select 6 from 17. So in A, you've got 17C6. All right, so using your calculator, where's mine? Right here. Again, there's that math button on the calculator. I punch in 17, I go math. Over to probability, NCR is number 3, check 6. So there's 12,376 ways to do that. Go ahead. 8 females, and I need 3 of them. 8C3 times 9C3. Okay, you get your answer. We can punch it in. So I've got 8 math.
Could you not use like the counting rule or whatever for this?
Shoot. Just a second, Rory. I'm gonna finish my thought and then right. Okay. Okay. So how do you propose you use the counting rule?
Like the lines or whatever. Like if there's 8 girls and you're trying to pick 3, can you do like 8, 7, 6?
No, because that's then ordering them, Rory.
Okay.
Right? That's a permutation. Okay? So the counting rule only works if it's a permutation, and there is a way to do it in this, in which you can use the fundamental counting principle. But let's say that this question specifically asked you for you're going to select 3 of the people, or 6 people, let's say. No, let's do 3. Let's do 3 people, and they say you need a president, a vice president, and a secretary. Then the counting principle kicks in. All right, so you can use it for that one because you have a specific order for them. But because you were just selecting 3 from 8 and 3 from 9, you just have to use the combination one. Let's look at C. One of the male students is named David. How many 6-member selections consisting of David, 1 other male, and 4 females are possible? All right, so we don't need to put it because 1C1, there's only one way in which you can pick David. There's only one way in which you can't pick David. All right. And then one other male, 9C1, and 4 females, 8C4 equals. Okay. So I need to know what 8C4 is. Should know it, but whatever. 70. So you have 9. This is 9 factorial times 70. So that would be 630, right? Okay. So this one was fairly simple because it was broken down very well for you. All right. Let's look at the second example. Okay, the second example deals with cases. So we don't change a lot with this, other than we're going to, when we do these questions, we multiply across and then we add cases together. All right. An emergency response team of 4 people is selected from a group of expert volunteers consisting of 2 doctors, 3 surgeons, 3 firefighters, and 4 nurses. In how many ways can the team be chosen if it must contain one of each type of volunteer? Okay, so here's an interesting part about this. All right, I can do combinations for this, of course. So I'd have 2C1, 3C1, 3C1, 4C1. So in A, I have 2C1, 3C1, 3C1 times 4C1. Okay, fairly straightforward, right? One of each type of volunteer. Okay, Rory, in this case, I could do this as well. I could use, all right, so I could put down here doctors, 2 of them, nurses, 3 of them, surgeons, 3 of them, firefighters, I don't know, I think that's what it is, 4 of them. So I could use the blanks for this one. All right, and then I would just multiply them through here, right? 12, 36, 72. Just, okay. And at least 3 nurses. So I need 3 nurses from the 4 nurses. So this should have been switched right here. Okay, so I need 4C3. All right. Then that means that I have to select 1 from the others. So that means then that there are 2 doctors, 3 surgeons, 3 firefighters. Select 1 from them. But we're not done because it said at least. So I could also have 4C4 times 8C0, which, of course, there's only one way you can pick all of them, and there's only one way in which you can pick none of them. So that's 1. But I have to add it on to the cases of 4C3 and 8C1. All right, so I think that's 32. The answer would be 33. Pretty sure for that one. Okay, so again, you add cases together, you multiply across your branches like you would do in the fundamental counting principle. They show you 2 full pages as to how to do it. All right. And the last of it is on working example 3, which is exactly the same as what we did with permutations. So there's not a big change on this, but we're going to do it with combinations. So it has the following setup. I have NC7. Okay. So it's going to look awfully complicated when we write this out, but here's what happens. I've got n factorial on top. I have n minus 7 factorial times 7 factorial here. And on the bottom, I have n minus 1 factorial over n minus 5 factorial, 5 factorial. Okay, so right now the setup looks relatively complicated to us. So we are dividing a fraction by a fraction, which means I have to multiply by the reciprocal of the second fraction. So when I do it this way, this will clean it up a little bit. Okay, so now I've reciprocated my fractions. Now basically what I'm doing here is I'm going to expand so that I can cancel out. And I'm looking at these two right here. So n factorial is n times n minus 1 factorial over n minus 7 factorial, 7 factorial times n minus 5, n minus 6, n minus 7 factorial over n minus 1 factorial. Oh, and I have a 5 factorial up here. Like that. Okay. So all I'm doing is taking the next and multiplying it by the next smaller number. And to multiply by the next smaller number, I subtract 1 to each one. Okay, so now I'm looking at this and I have that, done. That is done. All right, so what I'm left with right now, as I look, is I didn't do anything with the 7 factorial and the 5 factorial. I'll do that right away. But I'm just going to make this smaller for 1 second, and then I'll make it bigger again. So what I'm left with is n minus 5, n minus 6, 5 factorial over 7 times 6 times 5 factorial. There. Final answer. Is that. Now I could leave it as 7 times 6 because really I'm trying to find all the multiply it out. But that's where I'm at. Okay. Any questions about that? All it's doing is just expanding out your factorials so that you get to the point where you can cancel them. All right. We're okay there. And I'm going to leave B for another day. Okay, girls, any questions? All right. So you need to complete complete 11.1 and 11.2 for Tuesday. I'll do 11.3, which is binomial expansion with you on Tuesday. And it'll take a couple days. We'll have an assignment at the end of next week. And then from there, we've got about 10 days in which we can go through and do mini assignments to clean up this whole course. Any questions this morning about that? Or anything else for that matter? We're okay with the math? Okay. Grab your physics, girls. Grab that worksheet.